All right, so now that we know a little bit more about molarity, the last a little bit of this section that we need to talk about is how to be able to figure out how many ions are in solution. And so recall that soluble ionic compounds dissociate completely, right? So if it's an ionic compound and it's water soluble, it's going to dissociate pretty much completely. And so that's a strong electrolyte. And so to continue on with that idea, if you had a solution, let's say for example, 0.500 molar solution of potassium permanganate, right? There's two ions here. There's the potassium ion, and then there's the permanganate ion. Okay? And notice it's a 1-to-1 ratio. There's one potassium for every one permanganate ion. If you had a solution that we said was 0.500 molar, you could also say that was the concentration for the potassium ion as well as the permanganate ion. So you could say the molarity of just potassium ion is also 0.500 molar. And the molarity for the permanganate ion is also 0.500. And the reason for that is because of this. Think about it. If you had just one potassium permanganate formula unit and you dropped it in water, what would it produce? It would produce one potassium ion and one permanganate ion. So it's one formula unit produces 1 and 1. So if the concentration is 0.500 here, it also has to be the same concentration for these two ions. Do you see what I'm saying? And so we can actually show that down here. If the potassium permanganate is 0.500, so is the potassium ion, so is the permanganate ion. They all have the same concentration because it's a 1-to-1. Well, what if it's not 1-to-1? Like, for example, what if we were looking at Na2SO4? And what if I said Na2SO4's molarity was 0.35 molar? Well, think about it. If you drop one of these, one formula unit of sodium sulfate, what would it produce? It would produce 2 sodium ions, because of the 2 here, and it would produce 1 sulfate ion. So for every one of these sodium sulfates, it produces double the amount of sodium ions. Do you see that? And so what would be the molarity for sodium ion only? It wouldn't be 0.35, it would be double that. It would be 0.70. But what would be the molarity for the sulfate? Well, if you drop one of these in there, it will produce 1 sulfate. Since that's 1-to-1, the sulfate molarity would be the same as up here. Does that make sense? And so that's how you can change the molarity for just the ions if that's the case. And so let's look at an example problem. How many sodium ions would there be in 1.75 liters of this particular solution? So remember, molarity is moles over liters. Well, I know what the volume is, right? It's 1.75 liters. Okay? And we're going to be solving for moles of the sodium ion. But what's the molarity for the sodium ion? I wouldn't put 0.35 because that's the molarity for the whole thing. I want to know, since I want to know just moles of sodium ions, I need to put what the molarity is for the sodium ions. And that, we figured out, is the 0.70. So 0.70 molar is going to go there. And so I'm going to figure out what my moles are by taking 0, get that written correctly there, 0.70 molar, which is the same thing as moles over liters, times my volume, 1.75 liters. The liters will cancel, and that'll give me my moles of sodium. So let's figure out what that is. 0.70 times 1.75, keeping 2 sig figs, would be 1.2 moles of sodium ions. But I don't want to know moles of sodium ions. I want to know how many sodium ions. So we're talking particles, right? We're talking individual particles. So remember, what do we use for when we want to know individual particles? We need to use Avogadro's number. So a little review there. So we know how many moles of sodium ions, but I don't want to know how many moles. I want to know how many actual individual ions. So that means I'm going to use 6.022 times 10 to the 23rd. And I'm running out of space here, but sodium ions, there we go. So 1.2 times Avogadro's number, keeping those two significant figures. my answer, and I'm going to write it up here because I'm just running out of space. My number of sodium ions is 7.2 times 10 to the 23rd. That would be my answer for how many sodium ions there are. All right, now I'm not asking this question here, but I'm asking it verbally. What if I asked you to follow up, and what if I wanted you to figure out how many sulfate ions there were in the exact same amount? Would you have to go through all of this work all over again? Not necessarily. There's a trick to this. Because remember, for every one of these sodium sulfates you drop in, it will always produce one sulfate for every 2 sodiums. So if this is how many sodium ions there are, how could you figure out how many sulfate ions there are? Just divide that number by 2. Because there will always be double the amount of sodiums as there are sulfates. So if there's that many sodium ions, just divide that by 2, and that's how many sulfate ions that you have. All right, that concludes section 4. We'll see you next in section 5.